In this video, we are going to discuss about the design of a Schmitt trigger using 555 timer IC. In the previous videos, we have discussed many applications of 555 timer IC. One among the application is a Schmitt trigger. In this Schmitt trigger, this will be the circuit diagram for the Schmitt trigger. In this Schmitt trigger, the input will be a sinusoidal waveform and the output will be a square waveform. For a Schmitt trigger, we have two stable states, one on the upper stable state and one on the lower stable state. So we are going to measure the upper trigger point UTP and the lower trigger point LTP. In other words, it is also called as a upper threshold point or a lower threshold point. This is the component level connections for a 555 timer application for a Schmitt trigger. So you can see all other connections remains the same, and we will be using a regulated power supply and a DSO and a function generator. So you can see from the result that the input is a sinusoidal waveform and the output is a square waveform. Regarding the measurements, you have to measure the input sinusoidal waveform amplitude and its respective time period. Similarly, you have to measure the output square waveform amplitude and its respective time period. And as you see here, so this will be your upper threshold point and this will be your lower threshold point for a single cycle. So you have to measure for the entire cycles the lower threshold point and the upper threshold point. So you can see the two stable states. This is the upper stable state and this is the lower stable state. And the transition will be from here and then here. So that's all for the Schmitt trigger using an 555 timer IC. Thank you.